Hey, everybody. We'll give another couple minutes for people who still are joining, and then we'll get started. If you have your mic on, you might, if there's a background noise or something, you might want to turn that mic off. And we'll get started in 2 minutes. Thanks. Mhm. Hey, everybody. Thank you for joining. We will get going today. Just a couple logistics things. So I owe everybody a study guide for the quiz, and I'll have that out tonight. We had to get some software stuff sorted out, where I was signing everybody up so we could use Primavera, and I got to a point where they said, "Are you legally allowed to sign for your institution?" And then I had to send it to the dean and all that kind of stuff. So I'll have that. The study guide will come out tonight. If it's not tonight, it'll be tomorrow morning. I'll send out the instructions for downloading Primavera we will get, full use of the educational copy, and we will, that's what we'll be using for our first project. I think I briefly mentioned the point of the project last week, or sorry, Monday. The project, and you'll get the description that'll be on, with the Primavera software. We'll also have the description of the project. It's going to be, we're going to create a schedule for each one of you will create a schedule for your own project. The project is going to be, and it could be for any building you want. It could be your house. It could be your, workplace. It could be your office, your garage, whatever it is, to make some change in regards to address the COVID pandemic. So, the things some of the construction issues that have come up during COVID, and it's not necessarily in stone or anything yet, but ventilation is one issue that is being addressed in a lot of institutions, at least. They're trying to put better ventilation on air handlers or furnaces. They're trying to put increased ventilation, meaning you'll, instead of two air changes per hour, you'll have 6 air changes per hour. Those kind of things. It could be on faucets, your plumbing, hands-free kind of things, doors, whatever it is. I would like to, so you'll select a scope. And just as an example, it will be replace my furnace with a higher filtration unit to minimize the risk of COVID transmission. And so the point will be come up with what steps you would take on a project like that. This is going to be like it's a real construction project, and you are hiring out the work to contractors. So you'll, if you're replacing a furnace, do you have to open, is it in a furnace closet where you have to take off the door, or do you have to put some fresh air intake somewhere on an outside wall, or, whatever, maybe the furnace is going to get bigger and you have to expand the room, it doesn't have to be incredibly detailed. That's the point of it, is just to kind of get used to using the Primavera P6 software for, listing your tasks, making connections, or, your network diagram we talked about last time of what tasks are related to others, that kind of thing. What has to finish before, X task moves forward, and then the durations. So I don't expect more than, 10 lines around would be fine. So if you, six would be kind of the minimum, I would think. 10 would be plenty in terms of how many line item tasks you're doing, and they could be subtasks. Remove light fixtures and electrical connections for new furnace, something like that. So that's just kind of a brief description of the project. As I said, I'm sending out the project description that'll have the Primavera login information, and it'll have kind of a description of the project, like I just said. We'll be working on it for a few weeks at least, and in the Wednesday class, we can kind of go through some questions if people are running into barriers or dead ends. We can kind of talk about it and discuss what the question is, how you solve it. And I'm aware that everybody here has a different amount of exposure to the construction industry. I'm not trying to make everybody learn, oh man, I've got to get a 3/32 inch subfloor before I put down any new tile, or stuff like that. It doesn't have to be real technical. Just what you would think of in your head that would have to go and happen to complete the project. If you have questions on how it usually happens in construction, anything like that, just ask me, send me an email, call, text, whatever. Let me know, and I'm happy to help you work through it or explain anything that we're talking about. So I think it's kind of a nice little introduction, not so complicated where you're not familiar with what you're listing and talking about. But it'll give you some exposure to using the Primavera software, how to connect tasks and make one precede the other, that kind of thing. So, like I said, hopefully someone will get back to me. Francis was still emailing me a little while ago, so still we might get something tonight. If not, tomorrow morning I'll have the description out to you, and the study guide will go out tonight. So any questions on that or concerns, anything about the project where, and if we kind of talked about technology previously, I know possibly, I don't know if anyone is doing this class by watching it on their phone or anything like that. Considering we are going to be loading the Primavera software, you'll need a laptop or a PC to work on. If you do need that, there are laptops, I believe, available. Francis had quite a few. What we're doing won't take a lot of processing or anything like that. Doesn't need to be a very big, strong computer. Just, a glorified spreadsheet is all Primavera really is. So but if you don't have a laptop, don't be afraid to ask for one. Thank you. Good, Susan. I'm glad you're looking forward. So, any questions about that, or questions on how to approach it or anything? And I would encourage you to think about what we're talking about. If it might sound like switching out a faucet to a hands-free faucet is pretty easy, I'll tell you 10 steps right now that you would take that you'd have to do to address that. It's good to just get in the way, get in the mode of thinking about all the individual separate tasks that are involved in something. A simple construction project can still have a lot of nuance and complexities that take the only way where you're gonna be successful, or not the only way, but the best way to be successful is to break it down, understand the scope, and then kind of have a plan forward, and maybe even a backup plan or something like that to address unforeseen conditions, anything like that. But I think it's kind of there were other projects where you just get assigned a schedule and you're trying to do stuff. I thought it would be a little more personal if you had some input, some direction on what you're doing and why you would want to do it and how you would do it. So, sorry. Anybody have anything questions on that or anything? All right.
Yeah.
Yep.
So when you said 6 minimum line items, you mean as in a bar chart type?
Correct. Like,
Okay.
yes. So assuming we had a typical, I doubt anyone here is really going to be too interested in doing like a network diagram. I probably sounds like I'm knocking those. I'm not knocking those. Those are a good explanation of the logic and how to follow the logic. But in my experience, the P6, you input a lot of information, and at the end, you still pretty much get a bar chart or net chart with a lot of extra information and that kind of stuff. So that's how I proposed we would move forward on the project. Bar chart, 6 line items with like individual tasks or parts of steps in a task. Maybe the plumbing is, turn off the water to the house, drain it down, remove the old faucet, that kind of stuff. Secure the water supply valve so they're not leaking. Each of those kind of steps can be a line item task. And again, it's just trying to, get the relationships down, but also expose you to the Primavera software, which is Primavera is I wouldn't say the industry standard, but it's probably the most prevalent. I talked to a couple people about it, especially for contractors. Primavera is usually the thing, and for owners, like a hospital group or someone like that, a lot of those institutions use Microsoft Project. So, and then we also have a third software that I really liked that will take, towards the end of the class, we'll have a little experience with that too. So that's about it. For today, my plan was to keep going over chapter 4. That had a lot of information in it. And we got through some of it the other day, but there was still a lot of points that we didn't get to address. So I was going to go through some of the other points in that chapter and then do a couple together. We would do a couple examples just to see, so I can kind of verbalize my thought process and how I approach it, just to help you guys when you guys are doing the work to, an example of someone how it's done. And it usually helps me understand it, a little better than reading it, honestly. I can read an example and think I understand it, and then you ask me to do a problem just like it 10 minutes later, and I get all lost. So just kind of the thought process and not the exact calculation and all that kind of stuff is what helps me the most. So that being said, give me 2 minutes. I'm going to put up the chapter 4 slides so we can kind of continue through that topic. If anybody does have any other questions or anything else, today I believe is the final day if you were dropping the class to try to get 50% refund, I believe. Just hope no one's dropping it, but if you are, I'd like to see you at least get some money back. So letting you know that. All right. I will open that now, the spread PowerPoint. I got a question. Has anybody been to Triton in the last few days or been on campus?
No.
No.
Yes.
Yeah.
We have to go for Francis's intro to architecture class.
Oh, so that's an in-person class, huh?
Well, she says like the first few weeks we're gonna have to meet in the drafting lab to do a few assignments, but I guess
Yeah.
we're supposed to stop at a point. But I think I'm expected to be there at 9:30 tomorrow morning.
That's lovely. When's it supposed to start snowing? What time is that tomorrow? Because I'm gonna stop. I'm gonna go there tomorrow, I believe. So I just wanted to see who'd been around and how open it is at this point.
Yeah, we also have to check in the Campus Clear app.
Yes, right. That's important. 83. Tribe. No, I got one. Thanks. Construction project scheduling, critical batch at 4. Slides. Oh. Ah. 1 second, I gotta download it. Google Slides doesn't open PowerPoint, I guess. Condition. I'm sorry. Give me 2 minutes. I gotta get it off the other computer. It's didn't download folders for me. So let me grab that. I'll be right back. All right. I will share the screen. I see another comment. Share. All right. So we had gone through some of the critical path definitions, what it means, some of the terms used when we're talking about it. We did get into the description of, you know, how to go about putting together the information to determine the critical path. you know, we talked a little bit about some of the steps. One of the first steps was, you know, make it detailed, but not too detailed, basically. Too much information in that type of format can end up, you know, confusing the matter or making it hard to read. So it's, you know, it's you know, differing information, but it's just kind of got to be a feel thing. And when you make it and you can't fit everything on a page and, you know, all that kind of stuff, that's usually when you start maybe combining things or trying to make it a little bit more compact. And you can have a separate schedule for subtasks and for you know, programs, projects, whatever it is. The work breakdown structure, we kind of started talking about that. The activity description, the coding is just there to be able to get it a unique identifier, and sometimes the coding can include some descriptive information, even when if you're talking about how you break up your schedule, whether you do it into geographic locations or type of task, phase, all that kind of information. Who's doing it? That was kind of discussed on the last when we were going through the work breakdown structure information. We touched on, but we didn't talk too much about it. Milestone is a word you often hear in a construction project, and you know, I think it's pretty, you know, it's self-explanatory in that at least it can kind of tell you what it means in this context. A milestone is a defined point that, you know, you can use to gauge, are we behind schedule? Do we have some opportunity to cut some days out of the schedule because we completed our milestone? Milestones can also be a you know, precedence for some other task, or not even a task, something not even schedule related. It could be logistically related for the project. You know, certificate of occupancy is often a milestone. Sometimes it'll be, you know, receiving the building permit, pouring the floor if you have a slab on grade. It's just a meaningful, out of all the tasks, it's just, and you can have multiple milestones throughout a project. Sometimes you'll even have your payments tied to milestones. Just a quick aside, when you're working on a construction project, financing could be from an owner that has the cash. It could be from a lending institution. Sometimes there's a lot of oversight on how and how much is getting paid. So if you ask any contractor, they're going to ask for the bulk of their payment as early on in the contract as they can get it, really. But you know, once you pay the contractor, you don't have too much leverage in terms of getting it back or making sure he or she has done enough to warrant the amount of payment. So milestones, you know, you could have construction milestones, you could have project milestones like design development, schematic design. You can have owner related milestones. We switched over the air compressor system from the old one to the new one. And, you know, like I said, it can be, sometimes it's even payout related. So you want to be able to easily quantify exactly what that milestone is. How, you know, the worst thing you can do is make a milestone kind of ambiguous. That's gonna leave everybody in the project, you know, the room to interpret that gray area in their favor. So a contractor may say, you know, maybe the milestone is kind of left vague and just says occupancy. Well, that occupancy affects other things. There would be a relationship from, you know, occupancy on a bar chart to start of warranty period. You know, most projects have a 1-year warranty period on labor and installation. Sometimes they'll have 1 year, sometimes they'll have more in relation to the actual parts and equipment. But a construction project, as we know, can take a long time, and the difference between, you know, starting your warranty in September versus May can be a big deal. And you may, the owner's perspective, they only got full use of the space in May, but maybe the contractor got some, you know, occupancy clearance or moved people into part of the building or something like that, where he wants occupancy to be in October. You know, and it doesn't sound like, you know, so what's the financial impact? The financial impact can be very sizable. It can be very contentious a lot of times. You know, anytime you do a project, you touch an area, even if you don't touch certain components in that area, if you're working in that area, people are going to assume whatever happens is related to the construction. So maybe there's an exhaust fan serving a lab hood that I'm not touching, but I'm building out all the office space on the other part of the lab. Well, when that exhaust fan conks out, and, you know, nobody knows why it conked out, basically they're going to try to assign the responsibility for making sure that fan gets back up to the contractor. So that warranty period does really start to make a difference. After, you know, 4 or 5 callbacks, if you call a tradesman out for a callback, say, you know, my light switch is, you know, mislabeled and I'm turning on the wrong circuit when I hit the switch, this needs to be addressed. Well, if some contractor has to send out an electrician to deal with that, you know, it's serious money. It could be, you know, $500 to $1,000. Often, a lot of contractors will charge $800 to $1,000 for a day of labor, and obviously the labor guy is not getting paid all that money, but the contractor has overhead, and he has vehicles, and he has insurance, which is really expensive. The workman's comp, it can be serious dollars in terms of how much, you know, you pay out per hour, basically. So there's a lot of dollars in it, and there's a lot of headaches in it, and there's a lot of perception by the owner wrapped up in those milestones. So you want to make sure there's no question when you attach a milestone to a project that anybody can interpret it in any way but the way you mean. So milestones, very important. And there, like I said, there can be multiple. It's just, you know, what the project will determine what the milestone means and what it affects. Sorry, I go back up a little. So yeah, we talked. Here's some of the other factors when we're defining activities. Some of the other factors to take into consideration: size, duration. We talked about that. The geographic location or area or the floor, the nature of the work. All this work is associated with the new electrical service. All this work over here is the new electrical distribution. Just kind of breaking it up in your schedule that way might make the most sense. Timing, chronology, you know, what happens before what, how long after I install an air handler do I have to get the manufacturer out to start it up and test it. Level of confidence in the duration. You know, there's definitely certain aspects of a project that you can come pretty close on because it's a simple area to work in, and you know how much production your guys can get and ladies can get out of in a good situation with favorable site conditions. But you know, there's not too many of those on a lot of construction projects, especially renovation projects, just because of the amount of unforeseen conditions you run into. You know, you're not able to see through walls, and you know, when they start stripping the walls is when you find out, oh well, they they had cut off this header and re-supported it, you know, holding it up from the ceiling above instead of the deck below. So that's just another, you know, if it's a critical path item, especially, you know, you'd almost try to remove something with a very risky duration, try to almost keep that out of the critical path, because now, you know, your critical path has at least one, you know, wild card. You throw 2 or more wild cards in there and you have very little chance of, you know, being accurate on your critical path duration. Responsibility, breaking up a schedule based on who's doing what. The plumber's in for this time, and then the electrician's in, he's doing all this stuff. That's another way you break up the work breakdown schedule and or structure and your schedule. And then phase, obviously, we mentioned that. What's happening first before we can close down that area of the building, that phase 1, and then phase 2 is when we can switch over work areas. Activities, you know, a task, I call it a task sometimes. Activity is also another term for it. A scope, anything. You're just trying to, you know, when you break your project down, you want to have small definable scopes or activities that are easily understood and, you know, can be tracked and measured. So that's where, you know, the activities don't necessarily exist until you create them for your schedule. And not that I'm saying, you know, that the work doesn't exist, but how it's defined, tracked, and controlled. That comes from the person putting the schedule together. It's not, you know, just common knowledge or something you can just pull out of a book. You have to understand the project. You have to understand the location and you know, the other factors to make sure you can, you know, break down all your activities or tasks. The units of measure, we, you know, depending on what you're tracking, it could be a physical unit, it could be yards of concrete, linear feet, it could be a time unit in terms of work hours or man days or work week, all that kind of stuff. So all those things, you know, kind of go into putting a schedule together and should be considered as you put your schedule together, or just kind of break out an outline for your schedule. What do I think it needs to look like? Who am I giving this schedule to? What information do they need? And what, you know, liabilities or opportunities do I have? And how do I represent that in the schedule? We've talked a little bit about resource allocation. The schedule is the best tool when you're talking about resource allocation. If you don't have schedules, if you don't attach, you know, resources to those schedules in terms of man hours or crew size or anything like that, you know, a lot of companies are, you know, will be lackadaisical about that, and they won't be loading all that stuff in. You know, sometimes it's not needed. It's a small job. It's not a big deal. Maybe all your jobs are small jobs. It's not that big a deal. But in a lot of cases, if you're not loading your resources, basically you're not then, you know, kind of forecasting your future work. So, you know, it's not that hard to look at, all right, we have all these active jobs. I take the schedules from all those active jobs and I kind of, you know, in theory, overlay them, meaning I take the man hours or the man days from each of those 5 or 4 schedules, and I look at it and I see, you know what, in 2 months from now, we're going to have a requirement of 200 man hour or man days, and we only have, you know, enough people, enough tradespeople for 100. So that resource allocation is a huge part of schedules. ComEd, that was when I was working there and we would do construction projects, sometimes it would, and most of the time, honestly, when you would have, um, a sizable enough project where, it's not one guy for 3 hours kind of thing. If it's a sizable enough project and we would have to input our expected resources in terms of, um, you know, I need a foreman electrician. I need three journeyman electrician. I need two apprentices on site. That was tracked, for the whole company. There are, I don't know, 50 different locations for ComEd where they're in little different configurations and doing different jobs. But as a whole, we would track the requirements for, say, capital projects is what I worked on, meaning you're either adding something on to an existing building that increases its value or use, or you're replacing an old thing with a better and new thing. So for capital projects, they would have an assignment of, okay, we have 12,000 man hours available, 12,000 man hours available in the fourth quarter for capital project work. Inevitably, we'd always have, 5 times as much need in terms of, okay, we have 60,000 man hours of projects going on. So what are we going to do here? Obviously, that's when you turn to outside contractors, and you fill in your resource gaps with outside or independent contractors, whatever, temporary labor, or whatever, some form of filling out or responding to that big resource need in whatever, a month and a half or two. Because you can't, there's only so much overtime you can assign that is productive, and there's lots of other factors. You don't want to be hiring people and laying them off all the time. That's not good for anybody. So when we're talking about resource allocation, that's a big concern in terms of scheduling, and it's one of the biggest and most trackable and forecastable items that can really bite you if you don't do it well. And if you do it well, you can still get bitten because stuff moves around all the time. There's a storm and we don't have our electricians here for 2 weeks because they're replacing power lines. But all we can do is forecast as best as we know how with the information available at the time. So, but if it says you're going to be 50% short on resource hours in 1 month, maybe you're not going to be 50%, but you're going to be some amount. You can usually guess that it's not going to be wildly off. It might be off 10%, even 20%, but that should allow you to get into the range of about how many hours you're going to be needing for the next month. So forecasting is always a huge thing. A lot of people only think about cash flow when they're talking about forecasting or financing. That's always, forecasting is the primary concern there. But when you have labor, when you have especially in-house labor, meaning, and when I say in-house labor, I mean ComEd, say, would have electricians that work directly for ComEd. That's their in-house labor. They also had other tradesmen and tradespeople, like there were a couple plumbers on staff because they got pumps and whatnot all around. So the when you do have to deal with a labor force, you want to be able to forecast how much work you have and how much work you want to take in versus turn away. And that's where your schedule, when we talk about schedules, we're talking about a project schedule. Well, that's how you kind of integrate all those projects together and use it for the company as a whole. So that's most of the important information on here. Events and milestones, I've already rattled on about for enough time. Milestones, NTP. Anybody have an idea what NTP is in that context? So we're talking about important events called milestones. So a start milestone such as NTP. So it's some kind of start milestone. Anybody run into that before?
Notice to proceed.
There you go. Notice to proceed. And a notice to proceed, it's sometimes when you're engaging a contractor and you're having them bid the project documents, and there's all kinds of considerations in terms of legal on the contract, all that kind of information that may take a little bit longer just to sort out, you know, bonding, whatever the issue is. Sometimes you'll, instead of waiting until the formal full contract is signed by all parties, an owner or whoever can issue a notice to proceed, which will be, you know, in writing. Yes, you know, this is the project. This is the current estimate. This is my authorization to proceed with the, you know, excavation demo, whatever the first step is on project XYZ. So that's a pretty big milestone, or, you know, event in any project. Is what kicks off all the, you know, billing for the contractor, the work by the contractor, the submittal process, getting shop drawings of all the equipment that you're bringing in. That allows the contractor to jump on it, you know, without having to wait for the lawyers to review the contract back and forth 4 times. So substantial completion, I kind of brushed on that. That basically means you're, I think it's 90% definition wise complete in the project, meaning, you know, you are aware that there are still some outstanding items or outstanding scopes that will require completion. Like maybe you got to put sod down, maybe you got to wait a while to put that sod down, maybe you got to you put grass seed down and you have to wait for it to fill in. Substantial completion is issued is a formal document process, I'll say, or document/process that basically acknowledges, all right, you're mostly done with the project. We got a little bit more to tidy up, sweep up, but substantial completion might allow the contractor to take all of their money, except if there's retainage on the project. So just a milestone, and it's a term you do run into once in a while. There's other forms of occupancy, I'll call it. You know, there's for a town or a village to allow somebody to move into a recently constructed or renovated space, they issue a certificate of occupancy, and that's going to tell the owner, you can start moving people in, but, you know, you still got to finish all these tie up these couple things. That's it. A pretty important document and that you need from the village, and if they, you know, or town, and if they're still concerned about anything, they won't issue it, and that might not allow somebody, an owner, to move, you know, 80 employees out of this building that we're leaving and into the new space, or, you know, something like that. Then they got to readjust all their plans, all that kind of stuff. So occupancy, substantial completion, those are all kind of interim. There can be a temporary occupancy. Those are all just kind of iterations on a similar concept of, yeah, we're just about done, but we don't want to wait 3 months till we get the, you know, the special fan that was ordered for the director's office or something like that. It's kind of bad form to, you know, hold out, you know, retainage or final payment to a contractor that's already put in all their money. They've paid all their labor, they've bought all the materials, and if you're holding back on some small insignificant scope, it's bad form, and it can lead to, you know, relationships between contractors and ownership or whatever, whoever's representing them. The activity has a start date and a finish date. An event has a start date or a finish date. So small difference there in terms of events and milestones, activities. You start an activity and it might take 1 day, it might take 30 days. That is when you look at the Gantt chart, you see a line and it represents some amount of days. It's got length to it. A milestone usually is a single point in time. It might be an arrow at that point and not a bar graph. So just a small differentiation that it is meaningful in a certain way. So these are the work breakdown structures. We actually looked at this this structure here. It's not horribly detailed, but it does kind of break things down by division. No, it's not. No, it's not by division. So I thought it is broken down, just the identification of the post tensions, site work. Yeah, it's not the old CSI numbers or the new CSI numbers, but when you look at this from level 0, which is the broadest description of the project, we're going to build an office building in Tampa. That is level 0. As it whittles down through the work breakdown structure, it gets more and more and more detailed. And this this is not even, this looks kind of complicated enough. A lot of work is not shown on here. There would probably be more than twice, probably 2.5 times the amount of tasks that is shown here, because they're not showing all of the mechanical and electrical stuff, subtasks and more. So, and I just point that out to show that these things can get complicated. You're dealing with lots of different parties and lots of different tasks, and so I'm not saying it's too complicated to read, but you want to be aware of how complicated, how complex the things you're talking about are, because you need to find a way to communicate that information without making it too confusing. So, and you can see, starts out with almost individual trades, not even that, but kind of level 1 scopes are all pretty broad in terms of divisions, almost like sections of the drawings, the plans for the building, somewhat. And then, the next row down, that only applies to the building shell. That's not the breakdown from all the other divisions. So, you start with building shell, which is, the skeleton of the building, I guess you say, columns, shear walls, elevated slabs, all that stuff. You keep going down further and further and further until you're at very small and quantifiable and qualifiable tasks that you can confirm have been completed or not completed. Just gets more focused as you go down. Here's a kind of an outline representation of the same similar concept to that work breakdown structure diagram. This is an outline form of it. Very broad, concrete, and then more and more and more specific and focused. Concrete forming and accessories. Concrete forming then you're just talking about individual components you're forming in place, and so it just, like we said, it's gets more and more detailed, and you always have to kind of be watchful for making it too detailed that it confuses. So
yeah.
Yes, sorry, I took a drink.
On that previous slide, you said,
Yep.
don't forget, it said something like, don't forget level 0. What 0 meaning?
0 is just the very broadest. So if we look at this, it's actually above one there. Level 0 is we're building something. We're building an office building. So it's usually that will, and then there'll only be, not necessarily, but in most cases that first broadest level has just a single task breakdown, whatever we're calling it. And then it's a bunch of trees basically from that one level 0 task is what you use to create your work breakdown structure. And CSI, I think, you may or may not be very familiar with CSI. CSI is an organization that it's kind of a governing, I guess, or organization for construction standards. I think it's the Construction Standards Institute. Master format is just it's the new name for the divisions of work. The divisions of work are fairly standard throughout all kinds of different projects. And what I mean by that is, and sometimes the clearest way to see this CSI master format is in a specification book. So you got your drawings, and then you might have a separate spec book, and it's 8.5 by 11 size book binder of the specifications that give more specific and more detailed information than you can fit on the drawings. Drawings are diagrammatic. That's how they are communicating, and you don't want to have to put paragraphs of text on there that somebody has to, figure out and read, and that, might be half size said, all that kind of thing going on. So the CSI has used to be, they changed it, I don't know, probably 10 years ago, and basically it's just a listing of all the different different sections, divisions of construction work. So 0300 is concrete work. And as you can see, you break further and further down, you get more specific types of concrete and what we're talking about.
You know what, Pat? I'm sorry. This is Ayana. I did I'm also taking the specs and codes class with Becker. And yes, we go over that CSI. I actually copied it down like in the back of my notebook, and it's like up to 49 different divisions, and it's like some blank spaces left for like future and everything. So I thought that was really interesting how, like everybody probably should definitely go to that website now and look at it, because I really didn't understand that before seeing that. So
yeah, and you're right. That is there is a website. The CSI has a website. Sometimes I just, for me, it gets kind of wrapped up and confused with the actual product master spec is what people use for when they're writing specs. That's like a base spec. So if you're doing a project and you need to write a specification, that's like a base specification that not all specs in it, but it has a good portion of common specifications in it that describe, the 2300 section is plumbing, it's HVAC, 22 is plumbing, 21 I believe is fire protection, 26 is electrical. They changed I think it probably about 10 years ago, they changed those numbers to allow for more divisions, because in 20 years they're going to be building with stuff that we never even heard of right now. So you do have to leave room for future when we're talking about that. And that's just like you were saying, that the divisions maintained by the CSI kind of give you all those different all those different divisions and breakdowns of to. I've only ever gone up to, yeah, so I've seen like 33, but you know, I've only done a lot of, most of my career has been in kind of facility construction. There's also road construction, bridges, marine construction. There's all kinds of different parts of construction that, you know, you may never touch in your whole life after, you know, 30 years, 40 years working construction. But, you know, for another group of people, that's what they do every day, all day. Gas pipelines, um, wastewater. Actually, I've done 46. We did use 46 for wastewater stuff, power generation, and like where there's some sections missing. So like say 47 probably, there are blank spaces, 29, 30, and they tried to be smart about how they left those spaces so it's kind of fits in the um, general arrangement of the CSI specs. But if you look on the slide now, you can see all those divisions and what they are used for. Don't forget that level 0, Susan. Yeah, I know it is kind of confusing what they're asking you to remove, you know, not forget. Procurement and contract requirements doesn't really describe, you know, just the building or the general scope of the building or anything, but that's kind of separate, I guess, for the level they're talking about when they talk about the work breakdown structure. And so, yeah, that was a good point to bring up. You know, I use that a lot because when you're working on a project and, you know, there can be 200 pages of drawings, literally 200 pages of architectural, structural, mechanical, plumbing, electrical, technology now, all that stuff. You want an easy way to organize the information so you can find what you're looking for. So if I need to figure out, does the louver that I'm putting on the wall to suck in outside air, does that need to be aluminum or can I put steel in? I look at the spec and I, you know, run down the spec looking for where the louver is. There is a section metals. That's yeah, no, darn it, I was wrong. It's metals. So if I wanted to look and see that louver, sometimes you got to kind of think about, all right, what division is it? Louver usually is metal, but it's also kind of a wall component and all kinds of stuff. It's kind of related to the HVAC system, but just from working on it previously, I know that usually Division 5 has the metals and the extrusions and all that stuff in it. So usually that's where I'll go look for the louver. So the organization is done to help you standardize and to help you easily be able to use the information and, you know, work with it quickly, and, you know, and there's a logical constant standard you're usually working from. So 8:07, we'll take a couple minute break. We'll start back up at, it's 8:08. We'll start back up at 8:13, and we'll kind of maybe pull out some of the more important topics on these last few slides and maybe do a couple sample problems. So yep, we'll start back up at 8:15, just say. A little bit of time. And then I see you around there. Thanks.
Got it.
No. All right, we'll kick back up. Let me find my pen. It's gone. 1 second. All right. So, getting back to the PowerPoint for Chapter 4, and I just other logistic kind of stuff. Also tonight, I'm going to post the PowerPoints for all the chapters, so you guys can kind of use those too when we're looking at study guide that you'll have tonight. That'll be also available. I will not tell a lie. I am still working on trying to post the recorded lectures onto YouTube. My goal is to have that tonight too. I can't promise that yet, but just so all the information's there. One other slight point is the version that we're using is second edition. They no longer sell the second edition solutions and manuals and all that stuff. So if there's something on the, I've gone through it. I haven't seen too much besides there's some later chapters where they start talking about BIM and everything in the book. Besides that, there's not too much change, honestly, in the earlier chapters. So, but if you do see something that doesn't, you don't think you read before, I believe I'm okay to post the third edition of the textbook if you need to just look at something. But officially, I'm trying to stick to the second edition. If you see something that's not explained in the book, let me know. I don't want to confuse everybody. So that work breakdown structure we talked about, WBS. This is just kind of an example of just one trade where just concrete and how that's broken down, kind of how we were just talking, more and more just focused and detailed as you go farther into the breakdown. This is for concrete activities on a 25 floor building, 20 columns per floor. And it's just for concrete work. Here, FRP concrete work for building. FRP formwork, rebar, and placement. That just kind of, you can either cast your concrete on site, meaning you get a concrete truck, you set forms up, you install the rebar, or you tie that up all kind of suspended in space per the drawings, and then you pour the concrete into those forms and it sets up in a few days, and then you remove the forms and you got your foundation walls or your footings or whatever you're pouring. So here, they often use FRP. I often would just call that cast in place concrete. Just different terms sometimes. Concrete work for the building, the concrete work for the third floor, the concrete columns for the third floor. That's how many, how detailed everything gets. You can see the number of activities greatly increases in terms of the the amount of activities, the physical number of activities that can be represented. And when it's the big more general line items, it's usually fewer, and as you get more and more detailed, you have that number of activities goes up, way up. So you can see the 9,000 number. That's a pretty big number, but they're just talking about every piece of, when you say 9,000 activities for formwork for concrete column C4 third floor, that means they've counted, and there are 7,000 or 9,000. The bulk of that would be put this rebar that is, inch and a half or not inch, half inch thick, that goes right here and you tie it off and all that kind of stuff. So, you know, it just, and the only reason you're putting the number of activities, honestly, is to help you track and say, all right, we're done with the FRP work for the 3rd floor. How do you know? Well, we did the 9,000 pieces of structural steel inside the concrete, the reinforced concrete. When you can pour concrete and have no rebar in it, and it's just concrete. When you start adding concrete for, you know, for strength or shear strength or you know, resistance to separating shear strength, all that kind of stuff, it just gets, you know, more and more broken down and, you know, allows you, yes, we did 9,000 joints with the structural or the steel inserts. So that's just an example to try to show you, you know, how to go from, yep, we got some plumbing work here, to, you know, hot water plumbing supply, flexible connection. You know, it just gets broken down into smaller and smaller pieces. I talked a little bit about that confidence level. Sometimes, you know, construction has a lot of unknowns, and you're making a schedule, you're trying to get all the best information you can that's available at that time, but there's going to be some level of uncertainty. And when you start, you know, getting above a certain amount of unknowns and possible outcomes and outside factors that are going to affect your work, you know, you get too far along that curve of for the confidence level, and it almost doesn't make sense to forecast past that, because you're so far down that curve, that confidence curve, that, yeah, I mean, what's the point of me trying to say it's going to take 7 days to pour all the floors, or we'll be done by this date, because there's so many tasks ahead of it that have to happen, and each of those might have some uncertainty. So when you add them all, or multiply them, add them, whatever you're doing, the level of uncertainty becomes so great that, you know, it's kind of pointless to give a real solid number. You can maybe give a range, you know, 4 to 6 months, something like that, but you don't want to leave, especially a paper trail of being incorrect. And when you do that, when you have more and more degrees of uncertainty added, you're increasing the likelihood that you're going to be, you know, way off on something. So, and, you know, we've gone through some of the early chapters in the book, and there's lots of information and definitions and kind of technical practices, like with the logic diagram and the network diagrams. At the end of the day, you can only schedule a project if you know what's going to be happening within that project. Doesn't matter how much, you know, how good you are at network diagramming, if you don't know the sequence in which the installation occurs, or the different components can be assembled, all that stuff. So, you know, if you got too much uncertainty, then you try to be a little less certain on your, you know, pictures towards the end, down the curve a little bit more, because, you know, no point in, you know, you're probably wrong, so no point in trying to be wrong. So that's when you're throwing in kind of ranges of, you know, 5 to 8 months or something like that, just to acknowledge it and let everybody know that, yeah, it's going to take a while. Might be 6 months, might be 8 months. We're going to work our hardest to keep it on the low side, but you know, everybody wants to see an exact date. Obviously, you don't want to have to tell the owner, you know, he's going to ask you when can he have the furniture delivered, and if you tell the owner, well, there's a lot of degrees of uncertainty, and I don't want to, that's not what they want to hear. So you just try to present it in the most palatable way possible by, based on all these variables and possibilities. It'll be 4 to 6 months, something like that. So like I said, you got to be able to understand the construction, all the different tasks in a construction project if you want on a schedule. The best schedulers are usually, the most experienced, that know how to address uncertainty and know how to cover all the different parts of the scope without, unnecessarily burdening the project by saying, oh yeah, this is going to take 2 years. I'll guarantee, I'll stake my name on 2 years, but I know nobody's going to want to talk to me because the buildings has to be up in 1 year. So you just do the best you can and try to communicate as much as you can to everybody. The actual steps for when you're making a schedule, you have to somehow list all the different tasks or components in that schedule. You got to come up with an estimate of the duration of those tasks, whether it's 2-man days or 80 hours or whatever you're calling it. Most likely in any schedule, you're going to have to take a guess at that information. So a lot of people will try to be conservative, and that ends up turning off the owner too, just as bad as if you were short on the hours. If you told them it'd be done in 2 days and it takes 4 days, that seems like a fairly sizable mistake, but in the grand scheme of things, it didn't mean anything because I have to install a new CT scanner in that part of the building, and there's no reason I want to come in and mess up this part of the building until that's done. So, but when you're doing your schedule, you will have to estimate the amount of time. Best case is you have a company history kind of thing, spreadsheet of how many man hours were worked on a certain kind of project. That's your best guess, because theoretically it's the same group of people doing the installation, so hopefully it shouldn't change too much. Honestly, the second time someone does it, it should be easier, it should be faster, but that's not always the case. The units, we talked a little bit about that: hours, days, weeks, months. The duration the duration is the total quantity of some material or component divided by the productivity, meaning what quantity of X activity can a journeyman do in 1 day or 3 days or a work week. That's just kind of shown in that example. Total quantity is 10,000 cubic meters. They're probably still talking about concrete, I'm guessing here. Cubic meters, it's usually only used for, actually it's in this country, it's yards. We don't use too much cubic meters anymore, or ever, but everywhere else in the world does. So your 1,000 cubic meters here would, in most projects here, would be 8,000 cubic yards, or some variation on that. Cubic yards is what we usually use for area and volume, or 12.5 days, rounding up to 13. Those are just kind of little tips. How many crews? How many, do you have multiple crews? Do you have one crew working long hours? I think I talked a little bit about that, how you start losing productivity. In 8 hours, you might be getting 100 feet of pipe per hour. But when you stretch that out to 12 hours, it might go down to 60 feet per hour, because fatigue and location and all that kind of information can move and change the calculus on it. Multiple crews, I think I talked about that, how the difference between, and sometimes the losses that can happen in terms of productivity adjustment factors. That's used by estimators a lot, where there are some kind of mitigating circumstances. You know, installing 100 feet of 2-inch copper pipe in an empty, you know, retail space might be done a lot faster than that same amount in a working hospital. It might take 4 times as long in the hospital that it did in the, you know, commercial property. That's where you just try to look for some history, talk to the foreman, that kind of stuff, talk to the managers of the contractors or the directors of the in-house labor. You talk to them, you get your best feel for your best estimate on how difficult it is to complete work in a certain area, and then you might assign a productivity adjustment factor. So to account for, in Chicago, a good journeyman might install 200 feet of pipe in a day. In, you know, the south of the United States or Canada or something like that, it might be significantly less than an amount. So it's just important to, you know, you'll often be reducing, sometimes you're increasing it based on productivity rate, but in most cases, the thought is that you need to reduce it somewhat because it's, you know, high up in a ceiling and it's 20 feet tall, and all my sheet metal guys have to work off ladders. You're getting a lot less done than if they were able to, you know, in a home basement where they can just physically lift up the ductwork and strap it into place. So that's the adjustment factors. Accept unrealistic expectations. Very good advice. Couldn't tell you how to determine, you know, what the criteria on that would make some, you know, one task an unrealistic expectation and another task would be a solid or a more likely bet. You know, it's just, and I can't reiterate enough, where you're working, what type of facility is in, can you know, easily double the man hours for a project, especially a small project. So you just try to minimize the risks on those fronts. So, you know, don't always estimate the man hours based on what you want it to take and then what it can be done in this time frame, assuming everything goes, you know, swimmingly and there's not a big pitch to the floor inside the building, all that kind of information, and you know, all of a sudden you're taking responsibility for things you can't control, and that's why you don't promise anything that you know is not 100% deliverable in the time frame you're talking about. Define calendars, that's just, you know, sounds like what it is, and how you're assigning those resources or allocating resources, where you might say in October 20% of our workforce is going to go down to assist with the nuclear plant turnover or something like that. So some of the other steps for the schedule, and again, it comes with experience, knowing exactly how many steps there are. You're going to have to make your best guess and, you know, do some research, talk to professionals that do it every day, and that's going to give you your best estimate of time and duration, all that stuff. Talked about lags and leads, something that can, you know, I need to install the pump before I screw on the lid and pour the concrete floor, but that's not the critical path. So there might be a lag in terms of attaching or pouring the floor, because, you know, you might end up having to wait a certain amount of time where they're doing something, or other trades are working on other areas, and those are the more important areas. So you might have a big gap between you know, final install, whatever that would mean, and you know, end of warranty, essentially, how long that can be, and how do you adjust for that. External relationships, obviously, we talked about things that can influence a project that's not directly related to it. Pandemic comes to mind. Those kind of outside factors that can, you know, easily double the duration of your project, or half it, or, you know, anything you want, because schedules are always kind of fluid, and living documents is one way to describe it that I'm not fond of, but a schedule should not be created, turned over to somebody, the owner or something, and then never touched again. The best way you can utilize it is to, you know, track it against the project you're building and the assumptions you made, and see, you know, where you were inaccurate and where you were, you know, right, and all that kind of information. That's the best way to get the most value out of a schedule, because now next time someone does that project, they'll know that, you know, they'll know how long you guys had to wait, and you know, that will kind of define the start or the durations and stuff like that. Some of the logic points, again, it's just kind of general information on the logic for a network diagram. Establish relationships, the duration, start to finish to start, start to start, finish to finish. Those are for different activities, you know, critical path stuff. But logic versus logic versus resource logic. I think there's some slides a little farther back that give it a good definition of that. It's fairly simple in theory, but not that clear to just define in terms of context here. So I'll wait till we get a little farther on for that. Imposed constraints, those could be external, they could be internal, they could be, this place needs to be operating at in 35 days. This place needs to operate during construction, so construction has to only occur from 2 a.m. to 6 a.m., something like that. Those are not physical or constraints that come from the construction project or materials. It's not, you know, cure time for concrete, or you know, manufacturing time of ductwork. These are constraints that an owner, or, you know, a user, whoever it is, can add that, you know, might drive a good portion of the schedule. Again, just talking about the steps: draw the network, perform critical path calculations. Lots of terms and lots of kind of complicated sounding steps. In reality, it's a little, to me anyway, it's a little simpler than, you know, they make it sound. Obviously, you can break down tasks, talk to more seasoned professionals or somebody who does it every day, and, you know, you're not doing a critical path calculation in that necessarily right there. You're not, you know, drawing a network diagram, but that's the kind of activity that would be most useful in getting an accurate project, talking to the people who know the most. Review and analyze the schedule. You know, you can sit down, make the network diagram, or, you know, bar chart as well, or maybe make both of them. There's more than one way to skin a cat in any case. It's, you know, do we have to disassemble the air handler so we can bring it up in the freight elevator, or maybe we blow out a wall and, you know, can make a big opening so we can put the thing in, put the air handler in one piece, and then just, brick the wall back up or install new block or wall panel. It's a way to, the review and analyze is just a way to double check and see if there's any other ways that maybe you hadn't considered at the time that might, be quicker or faster, or quicker or safer, anything like that. Implementation of the schedule, taking the schedule, the document, and executing it and acting out all the tasks. This is, this is when the schedule becomes a control method and not just a forecast. It's a living document. You're inputting resources and time durations, and you can even put in cost and all that kind of information. This is the document that you're going to hand over to the owner each week, and you're going to show, good or bad, where your project's at, and you're going to have some logic related remedies where you're going to speed things up or make up for lost times by doing XYZ, by working 10-hour days instead of 8-hour days, whatever that is. That's where the control portion of a schedule comes in. But it has to be clear. It has to be, like I said, qualitative, quantitative. It's got to be completely locked in terms of communicating and incorporating that. If you have something on a schedule that it's not really, we're not self-performing it, but a contractor is doing, is contracted to do that work for us. So I'm not going to track the precedent, the preceding tasks for that, because that's on them. That's going to be a recipe to get caught with egg on your face, because nobody, when you're on a construction project, nobody cares if it was necessarily your laborers that made the mistake or it was a subcontractor's laborers. You are the single point of contact, so it's your problem. You can't pass the buck. So that's why you want to be very accurate and clear and concise, and schedule is a communication between you and lots of other people, and you want to be able to have confidence in your schedule, not overcommit, not be too optimistic in terms of we'll get that done in 30 days when maybe the owner didn't even need it until 45 days. So the more concrete it is, the more detailed that schedule is, the better your chance of success. I got there already, schedules. Like no. Some of the other implementation steps, the supplemental steps, compiling the information and disseminating the information can be a complicated process. Extremely detailed 300-line schedule that takes up pounds of paper. That might be useful for the superintendent or maybe it's the project manager from the owner, but in a lot of cases you're distributing schedules and you're going to tailor them to include the information that is pertinent to whoever you're giving it to. You want to be able to not get so detailed to confuse people, or get so detailed that you're going to cause questions when they say, why isn't your electrical contractor coring his own holes? Why is he hiring this out? At that point, when you get so detailed and people are reviewing it, they might try to get too far into it and start giving you input on means and methods that necessarily they should not be directing, but you know, they're the owner, so they can do what they want. The very essence of a schedule is to to document, coordinate, and control. You should be able to use that schedule as a tool and you know, as an incentive, as a responsibility matrix. All those things, you know, all of those things can be captured in a schedule and can be easily read, and it's just up to the person creating it to understand, you know, who needs what and why and all that kind of information. So that's implementation. The baseline schedule, that can be, you know, what the assumption is, but maybe you have a need to expedite certain steps to make up for a missed milestone on a different trade or something like that. That baseline schedule is going to be the baseline schedule when you sign that contract, or you know, sometimes it's from contract date, sometimes it's from construction start date. That baseline, even though you're using that schedule now as a tool to track and monitor and control, that baseline schedule is a contract document. That is the same thing as the drawings, the plans that the architect made. That's a contract document. It's going to, you know, live with the project for, you know, the duration of its life, and it's going to be what you're measured off against, the baseline. That's, you told me you're going to get it done in 45 days. Why now are you telling me it's going to be 60? And that baseline is going to establish what you agreed to in the original contract. So you really want to be careful in putting together that first schedule, that detailed schedule that you might see at a kickoff or something like that, because that then becomes the way what you are measured against. So monitoring and control, I think we've been through a few of these kind of a couple times. Reporting, documentation, how to implement changes, because, you know, something pops up during the project that may add days. Not often will it subtract days, but that monitoring control is how you're using the document to, you know, not just as a historical marker like the baseline in the contract. This is a tool now. This is a way for me to gauge our performance or our lack of performance. Communication, obviously, I've talked a lot about that. Database, that I talked a little bit. I don't think I used the word database. I think I used the history. The database is similar concept, where you have information on previous projects or similar projects that the company has completed that, you know, you can use to build your current schedule. The best thing on that, the best case scenario in something like that, is the project manager from that previous project not only just hands over the baseline schedule, but hands over the baseline and the final, and notes up, you know, we had this change which caused a 2-day delay. We had torrential rains where we couldn't drive trucks on site, and the more background information that you can have in that database, you know, in that history of your company's work, the more detail you got there, the better able you will be to interpret that data 2 years from now when you do a similar project. So that's it's it's not to assess blame or anything like that. Some people will, you know, be leery of changing the schedule because they know now I put it in writing that I extended it 5 days. Some people get leery about it. In practice, it should not be used, you know, as a bludgeon. In that case, it should be used for more successful project. But even if even if you're not successful, whatever happens on it needs to be saved and analyzed also, and used, on for future projects, then to establish maybe where your weaknesses are, or where something went wrong in that project you'd like to fix. Sometimes it's not so easy to point to that, right off the bat. You got to kind of dig in and figure out what's wrong. Why did we take so long to do that? You might find out that there was a structural crack at a column and you had to replace that column. Fair enough. That's acceptable, and you shouldn't try to hide it. Last couple places I worked at, some of the project managers would tell people working on their project, hey, don't charge my project heavily, or be light on that project, shift it over somewhere else. That defeats the whole purpose of an archive or history or database. The best thing you can get out of a project that you lost money on is that feedback that can help you, try to avoid doing it again. So it's to someone who's actually doing the work, sometimes that schedule can feel like a kind of a punitive scenario where they know they're being judged against it as well, and they get nervous, and they don't want to see schedule changes, and they'll try to avoid it. The whole mentality of the schedule has to kind of come from the top. We're not here to catch you doing wrong. We're here to try to get better at what we do. So, and it's not intuitive. A lot of people feel, automatically kind of defensive when they see a schedule and see that their concrete work took 3 extra days. So, it's there's a lot of trepidation sometimes with being too detailed, but you get less useful information out of it then. Budgeting, resource loading, we kind of talked a little bit about that, associating man hours or work resources to a task or to a project or to a group of projects. Cost loading, not necessarily, these are optional steps when you're doing your scheduling. Cost loading, none of these have to be in a schedule. It's just often done to help people understand. Construction project is long, and they need to, maybe someone's not so concerned with, when the occupancy date is, but they're more interested in cash flow because they're the controller for the company, and they know they need to keep a certain amount of cash on hand to pay the contractors on that project. So it's just, cost loading. I don't know how many people might have watched that Revit video with the showed the building going up in sequence and duration according to the schedule. It's one of the other factors that's like Revit is a 3D software. They've cleverly branded schedule to be 4th dimension and cost to be the 5th dimension. So all of that information is put into the building model, even, it can be a historical marker to show people what costs of piping was back in 10 years ago when they were buying that project out. All that information might not be useful to everybody, but it can be useful, and it can be added to the schedule. And materials procurement, that's always actually a big thing. I probably didn't touch too much on that. When we're talking about procurement, we could be talking, it can be a year. When I would replace a good sized transformer at a substation, it was 12 to 14 months to get the new transformer on site and in operation. And it was because it literally came from Germany on a boat across the ocean, onto a train, just the trip itself, from door to door could be, 7 days, depending on what kind of loading, unloading, what the ports or distribution facilities are like. So it's a hard thing to accurately gauge in some of those situations, but you just got to try to do your best. The budget, assigning budget to a schedule, I mentioned some of that stuff. It does help with the original estimate. And just like you track a project by its baseline, based on your schedule, the baseline schedule becomes, the Bible. Similarly, for budget, you can attach information about that budget so you get a better complete picture in terms of cash flow, how much a task took instead of versus, we thought we'd be able to buy 20 yards of concrete for this much, but it ended up being this much. All those kind of data points can be helpful to the right person, or can, if it's loaded into the schedule, it's at least there for, future examination and comparison, and all that information can be invaluable at some point if somebody knows how to use it. Where we at? 8:56. So there still are a couple, quite a few slides. I know this is a long section. I will try, and we didn't get to the calculator, the example problems. I'm going to write up a couple tomorrow just to give you guys some, some personal study guide. That way, you'll have the study guide tonight, but just some of the examples. If anybody wants to book time, please, I'm happy to do it. If you want to go through certain problems with us or with me, and the as I said, the diagramming that you're going to be required to do on, say, a quiz or a test is not going to be focused on the definition, exact mechanics or definitions. It's going to be on the concept behind it, and how to just how to be able to understand it in a general sense, so it can be used to show logic and relationships and all that kind of stuff. So, are there any questions on some of the information from 4? Like I said, a lot of information in chapter 4, and I kind of knew we'd be struggling to get through it all. I think there's 80 slides, a lot of redundant information, honestly, in some of them. But it is, up until this point, definitely the most useful chapter in terms of actual scheduling and understanding what goes into it, what comes out of it, all that kind of information. So, like I said, I will put all this PowerPoint will be on the website tonight, and I'll send an email out to everybody just to let everybody know that when it's all said and done, it's up there. Any questions?
What day is the quiz?
Let me. Is it a week? Hold on one sec. Course. So, and if you do need that information, syllabus is up there. On the last 2 pages of that is the schedule. I'm sorry, not the schedule, the syllabus. 215. So that's quiz 1. Like I said, I'll get the study guide out tonight, and then you'll have a week and a half to study, all the information. you can ask any questions you want from the study guide information or any other information that comes across. The study guide will have questions on it that are similar to what will be on the quiz. So the goal is to at least, it's not going to be the exact same, but same concepts and structure of answers and questions that you'll see on the study guide, that those will be on the quiz. All right, anybody else? All right, well, I appreciate everybody's attention tonight. Like I said, study guide and project definition with the software are imminent. If you have any other needs or questions, don't hesitate. I'm happy to do anything I can to help. And everybody stay safe and get your vaccinations done and watch yourself in the snow and have a good night.
Thanks. See you.
Thank you.
Thank you. Good night. What's up, Hershey? Yeah. No, we stopped sharing.